Everyone, welcome to Learning Python. Today we'll go into the infiltration, how to compute infiltration. So there is one very famous theory, it's called Green-Ampt, where we are looking at how the waterfront is moving in the dry soil. Soil is dry in the beginning, and as we get rainfall, waterfront is moving, and as water moves, the gradient reduces. So we see less and less water going, inside the soil. So we'll not go into so much into theory, but if you look at it equation, the infiltration, you can see we have this f term is coming two times, okay, and it's not easy to write this term as explicitly. So you cannot compute like previously you were computing evaporation is equal to function of, let's say, temperature and net radiation, etc. Here infiltration is a function of infiltration itself, okay. So you cannot follow the same approach, so we'll have to follow the iterative approach. So in this example, more than the how to compute infiltration, we'll look at how we can compute the how we can apply iterative approach to solve the implicit algorithm. So this is the final equation. So we are telling f is a function of other variables and f plus kt. To begin with, to make our first guess, we can assume this is negligible. This is our only initial guess, okay, not the final value, and we can say f is equal to kt. So now we'll open it in Colab. We'll define all the variables, how much porosity we have, how much hydraulic conductivity we have, how much the initial pressure we have, all these things we'll define. And then so first we are taking f old is the old gas we have, which is k into t, and we are using the while loop, or so we will keep on running. So in each iteration we expect our value to get refined. So when the difference between two iteration is less than the error is less than 10 to the power minus 4, the iteration will stop. So what it means, we'll compute iteration. We are telling in the beginning iteration is 1, or it can be any high value. If epsilon is this much, you run this iteration. So if we keep it very small value, our condition is not fulfilled, we will not even run one iteration. So the way to run it, in the beginning you define a value where it is higher than this, so that we run at least one loop, and inside the loop we should recompute it. So it will keep on recomputing it, and then when the value is lower than this, the loop will not run and will get much accurate value. If we want, we can keep on printing the epsilon. Let's see how it's varying. So you can see first we took epsilon is equal to 1, then it was 0.65, and quite it came to very low value at about 10 iteration, and then it becomes so low. So we can assume we have reached quite good accuracy, and that can be taken as the value of f. You can look at the same result, how the value of f is changing. So here we are using dash, which means continuous line. O means this circle symbol. K means black line. So by default we guess the the black line. With K we can say that we need the black line, and we are defining other attributes like, remember, if we don't define this font size, let's replot it, these are very small. So we can define font size whatever number you need for different things. And now we can read these numbers much more clearly. We can define font size of tick label also, like this you see 0, 5, 10, which will approach later. We can take other color also. Instead of black, we can take green, which we represent with G. We can take cyan color, we can take magenta color. So there are many color you can use. By default there is an order. If you keep on adding more plot, it adds it takes different color, Python takes different color, or numerical Python takes different color. Here we can see one more thing. Typically at about 12 iterations, f has becomes kind of stabilized, So because we had very severe criteria of stopping our iteration, which was 10 to the power minus 4, we could have tried less restrictive criteria. And let's look at how many iteration it takes. Okay, if you reduce 10 to the power minus 2, then it's taking much more less iteration. So it's up to you how many you want to run, how much accuracy. More the accuracy you need, more time it will take to compute. Since we are taking only one infiltration, it's not making so much difference. We see the result immediately. But assume you are have a watershed, and at every time step, let's say every day, there are thousands of grids. So even if 1 second or fraction of second difference can make a huge difference in how much total computational time it will require. So it will you will run it with experience, how much accuracy you want with the so there is a trade-off between accuracy and how much computational time you can give. So that's it. So we learned in this how to use while loop. So similar, now we are going slowly into the application side. First we simply learned what is the for loop, while loop. Now whenever there is a need, we are using those loops, we are solving the practical problem. And that's how you feel what is the purpose of that loop and how it makes our life convenient, how we can do something faster and easier way. So thank you, see you in the next session.